Hi, how are you? So allow me to teach you the concept, the wide concept of the area of a circle, okay? If you watch this video, you will never have trouble again with the area of a what? With the area of a circle. Now, this is a complete circle. And a complete circle has 360 what? Degrees, okay? And this kind of a circle, you get the area of it. You get the area of such a circle by pi r squared. It's that simple. That is how you get the area of a circle. So assume that you are given a circle whose radius is actually what? 14 centimeter, right? So you ask yourself, given these details, how do I get the area? So what do I do? I, as the student, what do I do? I know very well that Madam Sarah taught me the area of a circle is pi r squared. So we say you use pi as 22 over 7. That is pi. Then you have your r as 14. So you just say 22 over 7 times 14 times 14, right? So if you divide by 7, 1 by 7, 2. So in your calculator, input 22 times 2 times 14. Let me tell you, you'll get 616 centimeters squared, okay? That is how you find an area. The area of a circle is that simple. Another circle here, but this time around, you are given the diameter as 42 centimeters, okay? We know very well that if you divide the diameter by 2, you get the radius. So you just divide your diameter, divide by 2 to get 21, okay? Then 21 is your radius. Your radius is now 21. And let's say you use pi r squared, okay? So you'll get 22 over 7 times 21 times 21, right? In your calculator, input. Sometimes you believe in your head and your mind might be tired. So do not say, just input this in your calculator, times 21 times 21. What do you get? You get, okay, by 7, 1 by 7, 3. So 22 times 3, that's 66. Then you can input 66. You multiply by 21 and you'll get 1,386 centimeters squared, okay? That is just a simple way. Imagine it's that simple. Now, I have another application here. Imagine you are given a piece of a circle. You see, this complete circle here has 360 degrees, but it can be cut into very many shapes. These are semicircles. These are the quarter circles. They are called what? I just forgot the name. I forgot. So there is this quarter circle, which is here 90 degrees, 90 degrees, 90 degrees, 90 degrees, okay? You can also cut this by 2, okay? So that this part is just 45 degrees, okay? So imagine you're given such a circle where you are told that this part is 30 degrees, and then you have the radius as 7 centimeters, okay? Remember, I myself already taught you that a whole circle has 360 degrees, but this one is 30, okay? The formula remains, that is pi r squared. In mathematics, formula will never change. So what do? You just take 30 over 360, because I want to know the portion of a circle which is 30 degrees out of the whole 360. What is the area of that part? So 30 over 360, then you multiply by 22 over 7, then you multiply by 7 by 7, okay? So by 7, 1, by 7, 1. By 2, 180, by 2 is 11. By 30, 1, by 30, 6. So you just need to take 11 times 7, right? Equals, then you divide by 6. And you'll get 12.833 recurrent, depending on what you've been told to put your answer. I mean the decimal places you've been given. Centimeters what? Squared. Okay? It's that simple. It's that simple. In terms of triangle, in terms of, I mean not triangle, in terms of angles, this is what you do. Imagine you have such a circle, but you are told, but something like, okay, don't worry about what I'm drawing, okay? Assume this is a circle, and a part has been removed here. Let's say maybe it's this 30 degrees here, 30 degrees. Then you're told you'll need to find all the area of all these other parts, okay? You've also been given that the radius is actually 21 centimeter, okay? So what will you do? Remember, they've already removed the 30 degrees piece. What will you do? You'll just take 360, you subtract 30 degrees, and you'll get the other remaining part is 330 degrees, okay? So what do? You do as I had said earlier, 330, you divide by 360, then you multiply by 22 over 7, then times r squared, times 21 times 21. Okay, so you can just say by 10, okay? By 3, 11. By 3, this is 12, right? By 3 is 12, because 12 times 6 is 12 times 3. Yes, 36. Okay. We can just say by 2, 6. By 2, 11. By 3, 2. By 3, 7. By 7, 1. By 7, 1. So in your calculator, input 11 times 11 times 21. So you'll get 2541, then you divide by 2. So 2541, if you divide by 2, you'll get 1270.5 centimeters squared. Okay? Okay, I hope you've understood up to there. And the last concept is it the last or the second last? Is this. Imagine you have been given a quarter of a circle, okay? How do you know it's a quarter? If this part has this mark, which means this is 90 degrees. How do I know that it is a quarter of a circle? Because this is 90 degrees, and 90 over 360 by 9, 1 by 9, 4, that's a quarter, okay? So how do I input? Imagine you have been given the radius as 84 centimeters. What do? You just say, okay, we all know, do not forget that the formula of the area of a circle is pi r squared. That one will never change. So this one is for a full of a circle. So for a quarter, involve your quarter times 22 over 7 times radius squared times 84 times 84, okay? So in fact, 84 is divisible by 4. 84 divided by 4, so by 4, 1, by 4, 21, by 7, 1, by 7, 3. So in your calculator, input 22 times 3 times 84, and you'll get 5,544 centimeters squared. Okay? What about a semicircle? This is a half a circle. This is a half a circle. So assume that you've been given the diameter as 14 centimeters, okay? This one also does not change. The formula still remains as pi r squared, but this one will be for a half of a circle. So a half times 22/7, 14 is the diameter, so you divide by 2. So 14 divided by 2, you get 7. Then you multiply by 7 by 7. So by 7, 1 by 7, 1. By 2, 1 by 2, 11. So the area of this semicircle is 77 centimeters squared. Please follow for more.